This is Josh White with JW Math Tutoring. Today's video is going to cover Digital SAT Practice Test 4 from the Bluebook app, the Math section, Module 1. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just getting started on Practice Test 4, the Digital SAT from the Bluebook app, the Math sections, specifically Module 1. Just a couple things to remember. First of all, this video will most likely be over the allotted time, just because I like to show as many methods as possible to solve these problems. So there could be 2 or 3 different ways to get the correct answer. And second, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. So let's go ahead and get started with Bluebook Digital SAT Practice Test number 4, the math. So here we have just a basic essentially equation. They tell us what x is, and they just want to know what x plus 20 is. Well, 7 plus 20 is just going to equal 20. The correct answer for one, of course, is going to be letter C. And that's it. We can just move on to the next question. All right, here we have 2 data sets. They look very similar, except y has one more value. Notice that also the extra value in y is much larger than any of the existing 4 values that are in both x and y. So how would you compare the mean between x and y? So here's the thing, theory-wise, data set y is going to have a greater mean because the first 4 numbers are all the same as x, but then you add a number which is larger than the existing mean because it's larger than all the existing numbers. So the correct answer for this one is going to be letter B. The mean of x is less than the mean of y. However, if you couldn't tell that just by looking at it, that's fine. Then just go to Desmos and just find the mean of both of these data sets. You can just type in mean. Okay, the first one is 7.71. Now, if I just go ahead and add in the 27, okay, 12.53. So x, 7.71, y, 12.53. Obviously, the mean of x is less than the mean of y. So same answer, letter B, and we can move on. Here we have 2 triangles, which are similar. They're also right triangles, and they tell us which angles correspond to each other. So since we know that Q up here is 18 degrees, that means that P, which corresponds to it, will also be 18 degrees. Therefore, the measure of S is just going to be, 90 minus 18, which is going to be 72, or you could technically do 180 minus 90 and 18, i.e. 180 minus 108 and get it that way. So however you want to look at it, angle S is going to be 72 degrees. An alternate way you could do it too is you could say, okay, Q is 18. That means P has to be 90 minus 18 or 72. And since we know P and S are corresponding angles, well, then S also has to be 72. Since in a similar triangles, all the angles are congruent. Moving on now, question number 4. Here we are told how much of this propellant exists before this rocket launch, and then how much of it is left after, whatever period of time, and it wants to know how much was burned over each second. So it's actually not a difficult question. Really, all you're doing is taking the starting amount, the 467,000, and we're just subtracting from that the remaining amount. That will tell us how much was burned or how much was used up. That is 104,800. I can't read my handwriting. It looks like it's going to be 95. Now, notice it also asks how much did it burn each second. So this is the total amount that's burned, but we have to divide this by the 21 seconds. So you go ahead and you do that. You can just do it in Desmos or on your handheld calculator. It comes out to 4,995. So correct answer for this one is just letter A. That's it. We can move on to the next question. All right, question number 5. We have a system of linear equations. So notice here they're not asking for just x or y, they're asking for x plus y. Typically when they do that, you are able to just easily like add the two equations or subtract the two equations as they're written to make that expression that they're asking for and not have to do any work, not actually have to solve it. So in this case, if you just add these two together, okay, 4x plus negative 3x is just x, and then you have the plus y that comes along, and you add the right side, 20 plus negative 7, 13. What does x plus y equal? Oh, it's 13. Correct answer is letter C. Now, if you don't recognize that, that is fine. Then I would just go to Desmos, and I would just solve this system of equations. So just type in the two equations. There's the first one. There we have the second one. Where do they intersect? They intersect at the point 5 comma 8. So x is 5 and y is 8 for the solution. So what is x plus y? Well, 5 plus 8 is 13. Letter C, get the same answer. You can do it that way as well. All right, here we have question number 6, student produced response. They give you this equation, x is the number of on-site courses, y is the number of online. Um, and this is basically an linear function interpretation question. So notice 85 is total number of hours. That means each of these quantities right here, 10 times x and 15 times y, will represent total number of hours. Since x and y represent the number of courses, that means that 10 and 15 are going to be the number of hours for each type of course. So how many more hours does an online course take than each on-site training course? So they're just asking to compare these two. It's just 15 minus 10, which is 5. You know, 15 is the online because that's what the Y stands for. 10 is the on-site. That's what the X variable stands for. So 15 minus 10, 5. That's your correct answer. And, we just move on. There's nothing else to do. All right, number 7, we have a square. It has a side with a length of 12 centimeters. And we know that the perimeter of this square is the perimeter of a different square 2 times the perimeter of this square x. Okay, so what's the length of square y? So, okay, perimeter of square x is just going to be 4s, or in other words, 4 times 12. So that is 48. Therefore, the perimeter of square y, this is x, so for y, perimeter would be double that, 2 times 48, which would be 96. And then since each side is equal, we can just divide this by 4. So therefore, each side in square y would be 24. Now, notice you could also get this one by back solving. So you could like start with an answer choice. So for example, start with, first of all, a couple things. Uh, if you notice, square x has a side length of 12 centimeters, right? And we know the perimeter of square y is 2 times that. So that means square y is bigger. So each side in square y has to be bigger than each side in square x. So right off the bat, these two don't make any sense. So we don't even have to check them. So if you started with C, the way you would back solve it is you say, okay, each side in square y is 14. Okay, so the perimeter of y would be 14 times 4, 56. Is that double or 2 times the perimeter of square x? Well, you would still have to calculate the perimeter of square x is 12 times 4, which is 48. The answer is no, and then you could move on. And at this point, you actually would know it's D by process of elimination, but you could also check D, using the same thing. It's really not that much different in this case to use back solving, but you could approach it or think of it that way as well. All right, question number 8, basic linear function. And this again is just an interpretation type problem. How many gallons of gasoline are used to drive each mile? So here, gasoline is basically your y variable, and number of miles, or m, is your x. So what this is essentially saying is when you change the x value by one unit, 1 mile, how much does the gasoline change by? And the correct answer is 0.05. It's just the slope. It's just this number right here. Because when you drive each additional mile, the amount of gasoline will go down by 0.05. And you could just confirm this by just picking two numbers and like plugging them in, plug in 10 and 11 and calculate what the gasoline is that's remaining and compare those two values, subtract them, you're going to find the difference is 0.05. So correct answer is A for this one. Nothing else to do. Another student produced response for number 9. We have an absolute value equation. And this one, I will show you first how you could easily do this in Desmos. So typically, I like to, when you have equations that you're looking to solve, I like to type both of them in, set y equal to the left side, y equal to the right side. This one, of course, I'm going to zoom out. There we go, a long way. Okay. And now I'm just looking for the intersection points. The intersection points are going to be the solutions. So I either have 29 as an x solution or negative 27. So here it says, what is the positive value? So obviously I want the 29. So if x is 29, that's not the answer because we want 29 minus 1. So the correct answer for this is going to be 28. Now, just to show you how you could solve this by hand, so you can set up two equations. First one's going to look like the original problem, and you're going to add 4. So we get 4x equals 116. You're going to divide by 4. X is going to be equal to, let me just check here, 28. And now, notice since we already got the positive solution, you technically don't have to solve the second equation. I mean, it would really be 4x minus 4 equals negative 112, and that's where the negative 27 comes from. But we don't have to take the time, to do that now because we already got the answer to the problem. So actually, no, sorry, it's not going to be 28. Excuse me, it's going to be 29. Not doing this right. And then uh, you just subtract 1 from that, and that would give you 28. So in any case, correct answer, what you would grid in is 28 for this one. All right, number 10. Here we have a proportion, and they basically want this solved for x in terms of b and y. So easiest way to do this is to go ahead and just multiply on both sides by y. That would give you y over 7b equals 11x, and then divide by 11. Here's where it gets a little tricky. So it's technically y over 7b, okay, divided by 11. So what that really turns into is basically you do state change flip. So first thing stays, division changes to multiplication, then you flip, and the 11 goes to the denominator, so you get y over 77b. So the correct answer for this one is letter C. Now, you could also do this one using picking numbers. It's a little complicated because you need to basically pick two numbers initially for b and y, and then once you do that, then you have to pick a value for x, which will make the proportion true, meaning you get the same fraction on both sides. And then once you go ahead and plug, so then what you're going to do is you're going to plug everything in, and you're going to see which of these equations is equal. I mean, when you plug in the numbers you chose initially for x, y, and b, you're going to see which of these gives you the equivalent an equation which has the same value on both sides. That is true, essentially. All right, number 11. Here we have a table of values, and they tell us there's a linear relationship, so it's just a line between x and f of x. And they also tell us that f of x is in this form mx minus 28. So essentially, they give us points, and they're just and they already tell us the y-intercept, which is negative 28. They're just asking for the slope here. So easiest way, just pick two of these points. So I just went 192 minus 82, and then 20 minus 10. So 192 minus 82, you get 110 over 10. Therefore, what's the slope of this line? It's just 11, same as the question number. That's how you do it by hand. But you could also, of course, double check this and do it in Desmos as well. All you have to do is technically put any 2 points in the table. So I'm going to pick 2 different points just to show you and then do a linear regression and show you that I still get the same answer. Okay, here we go. M is 11. That's what we got. That confirms B is negative 28. That we already knew that, but that just confirms that, we have the same line. All right, so number 12, here we have 2 expressions that are being subtracted. And once you combine the like terms, you get some new answer, and they've already done the constant part, and that's negative 11. They just want to know how many x cubes do you have? So all we're really doing here is we're just doing 5x cubed minus negative, which is the same as plus 4x cubed, and we get 9x cubed. So therefore the value of b is just going to be 9, and that's the correct answer. No other work to do. All right, in question number 13, here we have a system of linear inequalities, and they give you a point where they give you the y-coordinate, but they don't tell you the x-coordinate, and they want to know what could the x-coordinate be, which is a solution to this. So, first way you could do this is you could just take the y-coordinate and you could plug it into the second inequality, because that's the only one that has an x in it. And if you just go ahead and solve that, we get 4x is less than negative 35. Divide by 4. X is less than negative 35 over 4, which is basically negative 8.75. So which of these values is less than negative 8.75? Well, not this, not this. Okay, not this. Yep. Okay, it has to be A. Now, you could also do this problem in Desmos. So let's jump back there. Let us graph both inequalities. What is going on here? Y is greater than 14. There we go. 4x plus y less than 18. All right. So x comma 53. Okay, so 53 is like, okay, so 53 is going to be like somewhere around here, okay? So on this line, whatever, I guess I could graph this line also, but if you look down here at the, different values, okay? Positive 5 and positive 9 are going to be like over here. No, clearly not in the solution set. Negative 5 would be somewhere around here. Again, clearly not in the solution set. Negative 9, yes, clearly is in the solution set. All right, so we can also get the solution here, as you can see, in Desmos, just again, letter A, it's going to be negative 9. All right, next question, number 14. Here you have a situation talking about bacteria, which is basically an exponential function. So you have 300,000. That's the initial or starting amount. So if you think about, y equals a, b to the x. A is 300,000. Okay, the number of cells doubles every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? So a couple things. If we're doing a doubling formula, then that means the b value is going to be 2, because doubling means multiplying something by 2. And x here will now basically be like it's essentially going to be how many doubles are there. Or if you want to think about it, really the way you set it up is you set it up as like x over 3, where you could put where x is the number of hours, because every 3 hours you would get a doubling. And then what you would plug in for x would be 15. So what you do, you end up with is 2 to the 5th, 15 divided by 3, and then that gets multiplied by 300,000. This works out to 9.6 million. The correct answer is going to be D. But basically, what you have to do, what you have to recognize is that 15 hours, when it's doubling every 3 hours, is going to be 5 doubles of the value. So in other words, it's like 300,000, and then it's going to be multiplied by 2, 5 times. So even if you don't construct the equation, you have to know that on your calculator, whether you're using Desmos or whatever, it's 300,000 and then times 2 times 2 times 2 times 2 times 2. All right, question number 15. This one, zoom out so we can see all the answers first. Here we have a graph of basically an exponential function, and they want to know the interpretation of the y-intercept. So notice the y-intercept value here is up at 9. So um, we're looking for something related to that, although it's technically going to be 9,000 because they tell us in the problem here the y estimated number of catalogs, which is y, is in thousands. So we're looking for something with 9,000. So we can get rid of C right away. We can get rid of this. Nothing with 9,000 there. Okay. So the y-intercept is always kind of like, the problem's like this: the amount, your initial amount or your starting amount, the amount, when x is equal to 0. So when x is equal to 0, that means it has been 0 years since the end of 1992. So in 1992, or at the end of 1992, the total number of catalogs that would present to customers would be 9,000. So therefore, correct answer is going to be D. A is talking about the total number of catalogs sent during the first 10 years. That's like basically adding up all the values, along the curve here at every single possible point. That's not, um, you know, that's not what the y-intercept means or what's described in this situation. All right, for 16 here, we have a radical, and they basically just want to know how to rewrite this in rational exponent form. So hopefully you remember that the index of your radical here is the denominator in your fractional exponent, and the individual powers are the numerator. So correct answer for this one is just going to be letter B. Now, just to show you real quick, if you did not remember that, here's how you could use Desmos to basically get the answer and match the expressions. So I'm going to put in a square root. I'm going to use different variables other than, actually, no, I don't want a square root. Sorry, you got to go over here to functions. This is what I want. I want the 7th root, okay, and I want a to the 9th and b to the 9th. And I'm just going to add sliders for a and b. I'm going to go to whatever random numbers, okay? All right, so when a and b are this, but now what I'm going to do is I'm going to run through the answer choices and see which one gives me the same value that I have up here. Which one gives me 8.99, whatever. Okay, A is not correct. Notice this matches perfectly. B is correct. This is the correct answer. And now you could also just check it. Put a 16 here for C. Obviously not correct. Way too big. 63rd is going to be gigantic. Yeah. Okay. So that's wrong. It's B. This is how you could get it also by just essentially what you're doing is matching expressions in Desmos. All right, next up, number 17. Here we have a population of a city increasing by 7%. And they want to know, well, what's that, basically multiplied by. So first, here's the theory behind this. You start off with some population, Okay, and you increase it by 7%. So that's the same as multiplying 0.07 times the original value. So when you add those together, what do I get? 1x plus 0.07x. Well, 1.07x. So the 2016 population, which is what this is k times the 2015 population. Well, the 2015 population was the starting amount, which was just x. So what do you multiply by x to get to 1.07x? Well, basically 1.07. So that's what k is right here. So correct answer for this one is letter C. Now, you could also easily just do this with a number, pick a value to confirm if you weren't sure. Say the original population is 100. If I increase it by 7%, that means I'm adding 7 to it. So the 2016 population is 107. How many times the 2015 population is that? Well, 107 is equal to k times the 2015 population 100. Divide by 100, and k is just going to equal 1.07. Same answer, letter C. You can use, again, picking numbers to figure it out if you don't know the theory behind it. Okay, here we have some system equations that want to know which has no solution. So I will tell you first, right off the bat, no solution is when you have two parallel lines, which means you have the same slope but different y-intercepts. Correct answer is going to be C, because notice these both have a slope of 16 but have different y-intercept values. However, if you don't know that, don't remember that, that's fine. Let's go to Desmos and just graph them out. And we're going to look for two parallel lines. So answer choice A. Do we have two parallel lines? Nope. All right, get rid of it. Here's answer choice B. Two parallel lines. Nope, they intersect once right here. Get rid of it. Answer choice C. Are these parallel lines? Well, it's tough to tell. You have to zoom in pretty closely to look at them, and you can see that, yes, they do appear to be parallel. They appear to maintain the same distance between the lines, whether you scroll up or down or left and right. And of course, if you check D, okay, obviously these are not parallel. They intersect at the point 0, comma 5 right here. So that's another way you could get this one, just answer this just using Desmos. Question 19. Here we have essentially an exponential function, but really it's a geometric sequence. So the first term of your sequence is 9, and then each term after that is 4 times the preceding term. Okay, so now they want to know which of these expressions represents the nth term of the sequence. So again, if you think about this, basically it's like 9 and then, times 4, 36 times 4, it should be 144 times 4, whatever that is, and so on. Okay. So first of all, the first term of the sequence is 9. That means when we set n equal to 1, we want the w value, the output, to be 9. So go through these answer choices and see which one gives us that. Okay, A. 9 to the first is 9. 9 times 4 is 36. No. B. 1 minus 1 is 0. 9 to the 0 is 1. 1 times 4 is 4. No. C. 4 to the first is 4. 4 times 9 is 36. No. So it's going to have to be D by process of elimination, but let's just confirm. 4 and then n to the 1. 1 minus 1 is 0. And 4 to the 0 is 1. 1 times 9 is 9. So this is the correct answer. Now, just to talk about the theory behind it a little bit, basically, since the initial term, the initial value is 9, that means that like when you construct this, 9 has to be on the outside. So A and B are wrong, right off the bat. So now it's down to C versus D. The whole thing is C would be correct if like the n values started at 0, not at 1. Like if they defined this such that n equaled 0 for the first term, then C would be correct. But because n equals 1, that's why it's technically answer choice D. And so on. Because we want, when we plug in n equals 1, we want 9 to be the output. All right, question number 20. So they give us kind of a description here in words, and they want us to construct us an inequality which matches this. So on this one, we want 12 less than, so we're going to be subtracting 12 from something. So right off the bat, I know these two are wrong because the 12 less than means we're taking 12 away. 6 times a number. Okay, so we're taking 12 away from 6n, and the minimum value of x is equal to this. So the smallest value of x. The correct answer is going to be greater than, because if you think about it, we want x to be like, this is the smallest possible value, and then we want much larger values. If you set it less than or equal to as an answer choice A, again, which is wrong, it's B, correct answer. If you set it less than or equal to, that's saying kind of the maximum. That's saying that 6n minus 12 is like the ceiling. In other words, x cannot get any bigger than that, which is not what you want. You want this to be the floor, and x to therefore always be above that or greater than that. So correct answer is going to be B. All right, for 21, we have two similar right triangles, and they want to know what tan of W is. So, okay, first thing I'm going to do is just draw a picture. So the longest side is TR at 52. So that has to be the hypotenuse, and that also means that S has to be the right angle because T and R have to be, in the corners like this. And then we know RS is 20 and we know ST is 48. Okay, so we can label that. Now, R matches up with U. So U has to go down here. S matches up with V, same position. V is the right angle. T matches up with W. Okay. So now, what is the value of tan W? So here's the thing. Angle T and angle W are both the same number, whatever they are. So that means like the tangent of angle T, so the tangent of T is going to be equal to 20 opposite over 48 adjacent. Okay, and you could just reduce that down to, looks like 5 over 12. So now the tangent of W is just going to be equal to that same thing, because the ratio of the sides is going to be in the same proportion because the triangles are similar. So it doesn't matter what the actual values are. The point is, like say angle T is, whatever many degrees, like 35 degrees. Well, W is going to be the same thing. So whatever the tan of 35 is, that ratio, or whatever the angle is, we don't know, is equal to 5/12. It's going to be the same thing for W. So the correct answer for this is going to be letter B. Now, question 22. Here you have a problem that can be done multiple ways. So one way you could do this, they're given this equation of this line. Okay, it's in standard form, which is kind of annoying, but you can rearrange it. And it's translated down 4 units. They want to know the x-coordinate of the x-intercept of the resulting graph. So, okay, first thing we could do, first approach, would be to get this in slope-intercept form. So x plus 19. All right, y equals 9/10 x minus 19 over 10. Now, move it down 4 units. So that means just put a minus 4 here outside. So now if you're going to go ahead and combine these, it's technically going to be minus 59 over 10. That can just be done in Desmos. So now so this is the new equation of the line, and now you want to find the x-intercept. So where does the x-intercept happen? Well, it happens when y equals 0. So you technically set, y equal to 0, and then you just go ahead and solve this. So 9/10 x equals 59 over 10. The 10s you can just multiply by them both and cancel out. X is going to be equal to 59 over 9. So that's the correct answer. You can grid it in that way. You can also put it in as 6.555. You can also put it in as 6.556 if you want to round the decimal. So either of those three answers would be correct. Okay, but now here is how you can do this problem in Desmos. You can save some of the work depending on the approach you take or all of it. So the first thing is once you get it in slope-intercept form, so let's say you get it equal to 9/10 x minus 19 over 10, right? Okay, so I graph that, but notice I define it as f of x. And then what I want to do for my new function is I want to take f of x and I want to shift it down 4 units. Okay, so I do that, and now what is my x-intercept of my new line? G of x. Oh, 6.556. There's my answer. Okay. So in this approach, you still have all of the work. Basically, like you're still doing all of the work, um, at least in the first half. You're not doing this, you don't have to do the second half of the work, but you still have to do like from here to here because you need to get it into slope intercept form. However, here's how you could also reason your way through this, doing the entire thing in Desmos, no work required. Okay, I graphed the first line. The original function I called f of x, right? Okay. So if it's being shifted down 4 units and we're looking for the point that's going to be on the x-axis, that means on the original line, which is, technically shifted up 4 units before the shift down, I'm looking for a y value of 4. So if you just graph y equals 4 and you see where they intersect, like this is the point that when you shift it down 4 units, it's going to be an x-intercept because the 4 for the y coordinate is going to shift down and become 0. So this is how you could get the answer to this question entirely in Desmos without needing to rearrange the equation, and basically do any of the work with the fractions or anything. All right, so this is the last question, on practice test 4, math section, digital ICT, the Bluebook app. This is the first module. So be on the lookout for videos on the second modules, both the easier one, which I call 2A, and the harder one, which I call 2B. But if you have any questions or comments about this particular module, please do leave them below. Otherwise, subscribe to my channel, sign up for notifications, um, and give this video a thumbs up just so that you never miss when another excellent math video is posted.